So this is the second presentation of the statistics seminar. And thanks to Dr. Van Santen asked me to present what, in terms of fertilizer rates, what has been done. This is quite broad for Florida, and I expect to narrow down what has been done before 2000 and after 2000. And of course, I'm going to focus on potatoes and the work that we have done with that crop specifically. So before 2000, so there are several trials, that kind of led to a recommendation, not only for nitrogen, but phosphorus and potash. But perhaps that was not enough, and more, we're seeing that has been increasing the needs for updating. In 2005, we're going to talk about a shift that kind of occurred in IFAS and kind of foreseeing what was coming down the road with the task force trend management. And what I want to highlight, in this introductory slide is I want you guys to see between the lines what the message I'm trying to pass along here. These are biological and complex systems. Sometimes it's very hard to find the answer that we're looking for in a single trial. We needed multiple trials, and just because this biological system is complex. Trials need to be mimicking the production settings. There is some controversies about large plots, small plots, as long as we're mimicking the current production practices. And let's keep in mind that they evolve over time. To give validity for this work, highlighting the importance of the extension work, including getting growers on the table and discussing these trials and discussing these results too. Role of cost share programs on the adoption of new practices, and of course the essential support of the IFAS stats unit. All right. Task force in 2005, between 2005 and 2009, we're seeing that there was a conflict. Conflict probably is too strong, but in between what the recommendation rates were that were developed in the 70s, 80s, 90s, and what the industry was using. So this task force put together through surveys and interviews and compare what the nutrient rate that the industry was using against the recommendation rate. And they found that it was not only the growers were using sometimes below the recommendation rates, sometimes at the recommendation rate, sometimes over the recommendation rate, for the crops, the main crops in Florida. But the quasi-regulatory, I think that committee was seeing that the quasi-regulatory, we're coming to the regulation, and that kind of became effective in 2020. Specifically for potatoes, looking backwards, there is the recommendation in the past was 200, 120, and 140 for nitrogen, phosphorus, and potash. And there was a reason that was around that. Looking back at the trials that were conducted from 1950s to almost 2000, optimum rate ranging here of 184, and the production marketable yield around 220 to 235. So for that level of production, their recommendation for nitrogen was appropriate. However, growers getting better in yield, and for several reasons. Here's the yield from Florida, from NAS, and as this is increasing, very steep, almost reaching 300. And keep in mind, these are statistical numbers. These numbers are probably higher on a grower level. These are probably higher. And there are several reasons for this increase, especially after 2010. Better control of diseases and the nematodes, adoption of the banning equipment. Here's a shout out to the cost share program. So most of the growers in the TCA area are banding instead of broadcasting. So that kind of increases the efficiency of fertilizer. Improved irrigation practices, another cost share program. Growers are getting better on managing irrigation, and that there is a direct implication on yield and fertilizer use efficiency. We're building fertility over the years. So these lands, commercial lands, have been receiving, especially phosphorus, over and over the years. So we have a good storage in some cases. In market competition, growers are getting better on their practices. So the motivations were there for us to start conducting trials to update the recommendation rates. And we started with nitrogen. So just stepping back a little bit, 2011, we had the numeric nutrient criteria for water quality. That was a big driver of these changes. The development of BMP practices, and more recently, the Senate Bill 711 that growers and landowners need to enroll to state BMP program. So here's going to establish a timeline where you're going to see how these trials evolved over time. The program for potatoes always had nutrients and water management kind of linked as much as possible. And we started looking at potato rate and timing trials and application, and this work was done in large with growers in commercial fields. And at the same time, we conducted trials looking at seepage water table management, and so looking into the interaction of this nutrient management and water. As the results are coming in, things were moving more towards, over different irrigation systems, economic analysis, and about this time, we were able to really come up with a recommendation for nitrogen on potatoes. The work didn't stop there. Around this time, we had colleagues from other departments also working in other nutrients. So correlation, interaction between the other phosphorus and sulfur become topic of study. And more recently, the later budget request, nutrient studies kind of supporting statewide rate for phosphorus and in potatoes, and for our nitrogen to other crops. Let's look at the crop specifically, potatoes. It's an amazing crop. It grows in 100 days. You can have more than 30 tons of biomass accumulated. And you see, the reason I'm saying amazing is the highest efficiencies that I have seen is with potatoes for nitrogen. We have a window for fertilizer application from pre-plant, and this can go up to 30 to 40 days before planting, all the way to tuber initiation. So after that stage, pretty much the above ground biomass is set, and it's mostly translocation. With that process is taking place, the response to nitrogen fertilizer is very reduced. So with that in mind, and another piece of information here, where are the potato roots? So this is a typical setup for potatoes in Northeast Florida, and a work done by Munoz Arboleda back in 2016, showing that 92% of the root length is concentrated in the top center. So that gives us the target for where fertilizer needs to be applied at the top of the row, discouraging broadcasting fertilizer. Anyway, let's look at the first set of trials that we conduct with growers. And we increase rates from 100 to 300, but we needed to answer a few questions. Meeting with the growers, they didn't want to give up on the 50 pounds pre-plant that they used to do. Although we're not convinced that that would be effective, considering sandy soils, very susceptibility to leaching. We agree with that. And the second application that they commonly used to do was at emergence. Okay, so let's increase the rates at emergence from 0 to all the way to 150. And the third application would be at tuber initiation. And then we range from 50 and 100. So this kind of design is looking at application rates at emergence versus side dress differently than the nutrient rate studies that, okay, 0 to 300, and then we apply everything at once. So that wouldn't work for us at that time. So set up at 6 growers. We sat with them. We discussed these trials. They didn't want these trials to be conducted at a research station. And so there was a lot of compromise at this point. And this was funded by the Dean of Research at that time. But that's another point. In the past, we were able to get funding to do nutrient studies. Nowadays, we have to be creative, include something different for a funding agency to be able to fund this kind of work. So we get funding from the Dean, and large plots, 8 rows, 100 to 150 each one. So here's the design. So each trial had about 3.73 acres nested in large areas. So we did with IFAS, the Hastings Center provided the application. So we calibrated the machine, applied, then the growers would take care of the rest, the crop management. Harvest was done in each plot in individual rows, and those were graded separately. So there was a lot of work. And just a highlight on how weather was also important in this situation. So here's the timing, 0 being planting, and nitrogen in the soil, and here rainfall. So this is the first year, 2010. So we apply 50 pounds here at this point, and rainfall was enough to pretty much leach that out. So by the time of the planting, we pretty much, seems that fertilizer was not there anymore. 2012, the same 50 pounds, because the rainfall was much lower, 0.8 here during this period, and 2.4, we were able to see the fertilizer. So that's kind of a situation we're dealing, in 6 different locations, different soils, different management. So to be able to capture all this variability, it took us 3 years. Actually, it took more than that, but for this specific design, to be able to. And then you can see that after the emergence application, we see the differentiation, the soil nitrogen increasing or decreasing accordingly. Here's an overview of the results. since we didn't have interaction, so we analyzed the main effects, and surprisingly, remember, this is ranging from 100 to 200. So every one of these rates received 50 pounds before, or 50 or 100 later. And here's the effect of each one of the emergence. In a few years only, in a few situations for one of the varieties, we were able to see this increase. For Frito-Lay, which is very common variety, for many years we didn't see that. One thing that was throughout the trials, no difference between 50 and 100 pounds at tuber initiation, so later on. So validating that high application at the end was not really beneficial. Accumulation curves, how much nitrogen these plants are uptaking. This was extremely important. This is actually what helped us to define. And for these yield levels that we're seeing, potatoes are taking up to 160, even sometimes even more nitrogen in the whole tissue. Yeah. And looking at the timing of application, timing of uptake, this is the uptake rate, ranging, very fast uptake here, between 30 and between emergence and tuber initiation here, 60 days. So that's another guidance for when we should apply, when nitrogen needs to be available to the plant. In parallel to these trials, we played around with timing. Here's another design, the single rate, applying or not applying nitrogen at the pre-plant. We're trying to make the pre-plant to go away, trying to prove that we're not necessary, and increasing rates. So pretty much working on a balance of early or late application. And for this particular design, we had to use orthogonal contrasts to evaluate. And then we start seeing that across 5 farms, only 1 farm had differences, which was here where application of the 50 pounds that the tuber at pre-plant was really effective, really improved the yield, but that was not true for the other farms. So you see, these results are sometimes not, because we're working with a universe of different growers, different farmers, different practices, different timings of application. So I'm going to keep moving on here. That's the last trial that I was going to do with pre-plant application. At that point in 2013, 14, we're pretty much done with that. We really want to get that away. And then we designed another trial with 2 growers, looking specifically at 0 to 50, increasing ranges for emergence, same way we did before. However, for the last application, we already knew that 50 pounds was enough for that situation. And dry year, it's a very low amount of rain until towards the end, and a more regular year. So we were able to see the nitrogen from the pre-plant application stay in the soil for longer. And you see that in wet year that pretty much washed away. This is probably what convinced growers to keep that pre-plant application. Looking at the yields here, the first year with the dry year, we didn't have an interaction, but we saw that there was not having the pre-plant, we had a decrease in yield, a significant decrease in yield. Similar results with increasing, so now this is becoming more clear, the emergence where we should be. And for the wet year, we saw a completely interaction, where we're losing fertilizer at the beginning, you need to apply more towards the end. To really seal the deal with the timing, we use 15N to look at specifically each application timing, how much of that fertilizer is found using in the plant, and the real efficiency of ammonium nitrate using isotopes. So basically, we have the same rate and labeling different rates. That way we can look at the efficiency. And what we see here is from that pre-plant application, 30, 40 days before planting, only 11% of that fertilizer is recovered in the plant towards the end. And here's the amazing plant, about 62 for these two applications. This is very high, but overall we're looking at 45%, which is expected for crops like potatoes or corn. The second trial that we did, we moved that to planting. We increased the efficiency for the pre-plant fertilization, for the initial fertilization, in this case at the planting, right before planting, and decrease a little bit for the second one, but keeping the same one high. Overall, 41%. So it's quite similar overall efficiency of fertilizer. What did we learn? Rainfall has a strong effect on availability of nitrogen in the soil. Potato needs nitrogen early stages, pre-plant or planting. So we advocate for planting because that's when you have a higher efficiency. That's when you have less risk of losses. And now applying fertilizer. We wanted to apply fertilizer only between emergence and tuber initiation, but ignoring that, we're already losing yield right off the bat. For emergence application, we're ranging between 100 and 150 pounds of nitrogen. That's depending on the variety. Tuber initiation, you're going to see from the next set of trials that pretty much, if things are going okay, you don't have to go too much at the end. But if you're losing nitrogen through water over the season, so you probably need to increase a little bit the late application. So with these sets of trials, we start looking at, okay, above 250, we're not getting much out of it, increasing yield. Below 200, we are putting the crop to, it is possible to grow, but conditions of rainfall need to be really, really minimal. See how much time. So we continued the work, and I want to highlight this because the influence of rainfall in the water table management really plays a role on nutrients. We open an area at the research center, and these seepage areas, they have a slope of drain and subsurface flow that was towards here. So we took that in our advantage, and we established nitrogen trials in each one of these positions. And with this slope, we were able to pretty much keep the water table in the different levels. So since here's the drainage area, so we expect a higher water table compared to this area, which is the top of the hill, which is still pretty flat. This area is about 15 acres, and within, you see those three beds over there. So here's an example of each one of them. So we put 3 nitrogen rates from 0 to 300. We also, and this is completely moved away from that kind of design. So we're interested in the total amount. So we split the application accordingly, that table. We also include 2 other varieties as a split plot. We included several terms here that today, if I was gonna redo this work, I would change this. I would simplify this a little bit. So here's again the water table targets. So we use automation to keep that water table near this depth, 15 inches below the top of the row. And we use each one of these blocks later on as a covariant to look at the effect of soil moisture and water table on yield. First here, think about a grad student that is freaking out after seeing 9 inches of rain in 3 days. This was, and the whole trial underwater. That's what's happening. And that pretty much, after that point, we didn't irrigate, just drain the area over. That significantly impact the yield, especially an impact in a way that where the higher water table was, more rocks we saw. So here's an overview of the day before. It's pretty sad to see how this water draining from the alleys here. But you can see it through zero nitrogen, see the rates there. First thing that we observe, we also measure roots, is by keeping the water table in the different levels, we saw higher colonization as when you keep the water table lower. Here's the more than 50%. This is the total root length, especially in 20 to 30 centimeters depth layer. And same thing for the next year. So by managing the water table, lower as possible, not compromising yield, we also see higher colonization, and that implicates in higher uptake in theory. Here's an overview of that covariance results. We have soil moisture on the axis here. And here's each line represents the nitrogen rates, and here's marketable yield. So because of that, and this is the average moisture of the season, because of that rainfall event, that pretty much skewered the moisture, the average moisture higher, and then everything that was around above 18, 20, which is pretty close to the higher than the field capacity, we saw a decrease in yield, significant decrease. But a year that was regular rainfall, we pretty much didn't see an effect of this. You could keep the water table in each whenever you want, although you're increasing. As higher you keep, your risk of losses. Anyway, so water table has an impact, so we're looking at to keep as low as possible. Although growers are not penalized to keep it high, except when there is large rainfall events. But there is a significant reduction in water by keeping the water table as low as possible. And now we're also conducting more studies looking at this capillarity factor, depending on the soil texture, and to see where, across the PCA, where we should keep to guide the growers where the water. Giving continuity to the journey of irrigation versus nutrient management, in around 2011-12, we're seeing these new irrigation systems being adopted by growers. And tile being the most popular. Today we have about 7,000 acres already converted from seepage irrigation to tile. Well, 700 and about 3,000 with sprinkler. So we felt that we needed to really study this in depth, and there was an opportunity to contrast. So we got funding for irrigation, and we included nitrogen trials there. Fortunate to have this facility in Hastings, where there are 4 different irrigation systems, and we put nitrogen trials there. And at that time, we already moved from the pre-plant fertilization. So we want to really wrap up our study at the level of between planting and tuber initiation in terms of timing. And that Dr. Van Santen helped us with this design, that 3-factorial design using, since we didn't have replication of these irrigation systems, we replicated over time. So we have this, and then irrigation was replicated over time, irrigation in the main plot, nitrogen versus timing in subplots using RCBD, and year repeated management. That's the design. So planting ranging from 100, 50 or 100. So total nitrogen from 1 to 1. We're fortunate to not have interaction. And for the fact that we could come up with one recommendation of nitrogen across our irrigation systems, that was good. And instead of having different recommendations for each one of the systems here. And just to highlight the water savings, again, the water savings of these irrigation systems, 30 to 70%. That's a path, a step forward on sustainability for that region. Yield in terms of the across the irrigation systems, we saw a very interesting, especially tile yielding 8, and SDI about 8%, 13 and 8%. It's pretty much similar. Marketable with the same thing. So we're seeing that on top of the saving water, we're also getting higher yield. And that doesn't even count because style drainage in the commercial area would also include the furrows. So growers would have those furrows cultivated. So that's another gain of 12% of the area. I attribute differences in yield basically on how fast these systems can drain. So here's water table level after, and bars are rainfall. Here's the water table level. Seepage in this situation here, took about 69 hours for the water table to recede to the same level that was before. And that can be achieved with 32 hours with tile. So that difference can really help, especially potatoes, which is sensitive crop to logging, in the yield potential. Here's a picture of, this is a drain tile after 2 inches of rain. It takes a while to drain. In terms of nitrogen response, there was an interaction between emergence and planting and emergence. Now we're looking here. When you have low nitrogen at planting, it requires higher at emergence. So we start now playing with this. And don't think this as a nitrogen that was applied, but think this as nitrogen that has been lost, after rainfall or situation like that. 100 pounds at planting requires 50 pounds at emergence. And then tuber initiation and emergence, 50 pounds at emergence, low levels of nitrogen at emergence requires higher. So I think this gives us really an interesting way to, okay, what's happening throughout the season? How can we manage? What are the tools? How late is this too late? And how much we can apply? So give us all the answers that we need. And how do you put all this together? That was a challenge. That was a challenge throughout the pandemic. And I think we got it done. When we collected all these trials, we started looking at the variability between farms, between seasons, you know. And here's the total marketable yield for all those trials conducted over the years. And here's the nitrogen uptake, the corresponding nitrogen uptake. So we see that plants are uptaking between 75 to 160 pounds of nitrogen for this respective yield. When we put that together, so we were able to draw this correlation. As tuber yield increases, potato nitrogen uptake also increases. And that's the fundamental part for to draw the recommendation. We also have the nitrogen use efficiency for this fertilizer, and this is the overall efficiency, looking at pounds of biomass produced by pounds of nitrogen. As we increase nitrogen rates, efficiency decreases. That is expected, and that's what we're able to determine based on the data that we had. And look at the 200 pounds here. It's pretty much matching with what we observed with 15N studies, about 45% efficiency. So we're pretty confident with this efficiency here. Looking at all the trials together, analyzing it as a total amount of rate. So we see increased quadratic curves, peaking in around 224 pounds of nitrogen applied, and this is yield. Putting that together, we have yield, nitrogen uptake, respective nitrogen uptake, and including when we multiply by the efficiency, we can have this nitrogen fertilizer required for each one of the rates. So basically, if we're a grower that you have constantly an area that's constantly producing 400 bags, 200 pounds might not be enough, because potatoes require more nitrogen for that particular. On the other hand, if your area is not reaching more than 250 and you keep applying 400 pounds of nitrogen, that's not the limiting factor. There are other factors that are limiting the production, and that need to be addressed before nitrogen. So that's kind of the message we're trying to convey to the growers. Then we presented this to PNOC back in 2021, and this became the recommendation for potatoes, looking at yield goal with indications on how to split the fertilizer between planting and tuber initiation. And we also look at the economic return at that time. That probably is obsolete because that was before the pandemic. So that was a long journey, to get to this point. But it was at that point I was very confident that the data that we collected lead me without question to raise the recommendation from 200 to 200, based on the yield goal, 250 pounds. All right. What's happening right now? So we have other faculty working on potatoes as well. Dr. Liu did a few trials on phosphorus and correlation with calcium. We have Vivek Sharma in ag engineering working on more well-drained in live oak area, soil moisture sensors and nitrogen, and doing a really good job there. So it's kind of complementary work that we have done in the TCAA with the soils with water table. Dr. Lakesh Sharma has been a great partner, and we're looking at interactions of nitrogen, sulfur, and all this here. His students have been working quite hard to get that. So in the future, In the near future, I think we will be able to update not only nitrogen's already updated, but confirm nitrogen interactions with all these other nutrients. Dr. Lu did a series of trials of phosphorus, looking at with growers. That was before the LBR. Very large plots of 1.2 to 1.6, experiments ranging from 14 to 22 acres. You see that we have only 3 rates, and for one farmer, 4 rates. That was the trade-off we have to do to manage this type of harvesting a whole acre and then have them to wait. That's a very cumbersome. And I personally don't think we lose significance or power to compare treatments by working in a more reduced trials, size plots. But this work was done. Here's an example of the strip plots that were conducted. So in combination with these results and the results that the other trials that we are conducting, I think we will be able to really wrap up the phosphorus uptake. And I would use the same process of uptake, how much phosphorus is required in the tissue, the uptake, the demand of potatoes, and use that with the rates to be able to draw a new set of recommendations. We're looking at the liquid application with pre-plant application. I'm not going to show any results. I'm just going to go through what we're working on. The LBR, the large LBR that started in 2021, we're looking at several crops. Potatoes is one of them, but tomatoes, snap beans. And so we're working as an institution, we're working towards really updating these recommendations. We're also using crop models and artificial intelligence with the data that we're collecting to move forward. Field trials are very expensive, and I think nowadays we have ways to improve the recommendation. Just to another example of the phosphorus trials, we're conducting 6 rates in 6 locations in Northeast Florida and 2 more locations in the South. And we're following the similar design that we did for the initial trials that we conducted. Relatively large plots, but in a way that we can manage it very well, and we can harvest and get accurate measurements of yield. Timing trials, can we, similar to nitrogen, there is a philosophy that applying phosphorus early in the season, it's good. We're not trying to debunk, but we're trying to see how early can we apply, because we know as you apply for phosphorus in the soil, it reacts with the soil parts, iron and aluminum, and become not available to the plant. So we want what's our timing here? Are we talking about weeks? Are we talking about months? Let's target maximum availability to the plant. Continue work. This is an automation trial. It's another trial that we get funding for irrigation management, and then we put some nitrogen trials inside. This is a nitrogen and phosphorus interaction. So we're looking at the interaction of the elements. All right, wrapping up, and a little bit of what I'm expecting towards the near future. Site-specific recommendations, we need to keep those in mind. Us that we're designing these recommendations, very hard to come up with one size fits all, and if so, we need to be creative on being able to collect enough data that we need to look at this variability. But site-specific, it's something that we need to address. And there is a team on that LBR project addressing that. Nutrient requirement. I would put this in the first priority. We need to look at the requirements of each one of these elements for different crops. That drives a lot of the efficiency, that drives a lot of the amount that we need to. Refinement of soil nutrient testing. There is the group in the soils department that is working hard with this, and this is also fundamental and very linked to site-specific. Without this piece of information, for example, for potash, the soil testings are really unreliable, at this point. Additional measurements. Every time it's possible, soil moisture, water table. Dr. Lakesh has done a lot of work on NDVI, images. The AI is looking at satellite and drones. So those are going to move us forward. The data availability, FDEX has a new template. We're fortunate to work with them. So these trials that we're collecting in the LBR, we will put that in the template, and that can later on be used for crop modeling or AI purposes. This is very important, and it's overdue. Crop modeling and AI, we see a lot of this coming up in extension. So this work would not be possible without the growers, without the county agents that support us. Talking to the growers, making the connection, from the research team, and so that's extremely important. So special thanks. I think there is a you're going to see the next slide that try to include everyone, and probably not fair, but growers. Without them, this work wouldn't have the meaning that it has. Funding agencies, everyone here, FDEX, the Office of Ag Water Policy, is really a good partner here. Water Management Districts, St. Johns County, the Hastings Ag Center. That team is fantastic. That helped all of us that have trials there tremendously. The extension team, the extension faculty in the TCAA and other counties, they're an excellent team too. The hard science, my home. I had a home in the AB as well, but hard science is what's paying the bill, right? IFAS Statistic Unit, thank you, Dr. Van Santen, and then your team. I've been working before with your center, your unit before you arrived. Mihai was one that helped us before. The clue, thanks for the invitation. And all the grad students and professors, technicians, and that helped us. Open to questions. Hope I didn't bother you.
Room first. Oh, excuse me, I meant this room. I'm so sorry. Becky's working on the Zoom, so.
All right.
She said she's gonna open the chat and you should be able to read it.
Okay.
Okay, I'll have a question. Can you go to your slide with nitrogen, the field nitrogen use efficiencies, where you see a decrease in variability as you increase the rate? Yeah, right here. And so would the increase in nitrogen fertilizer rates treat the differences between different locations? Because I assume each rate is a summary of number of different locations. And in the little time I've been here I've heard that all recommendations in Florida are extremely site specific. So do you eventually outstrip, or overcome the site differences if you just hammer it with 300 pounds per acre?
Might want to repeat the question
Oh,
for Zoom people.
let me see if I get this right. So your point is the variability across farms. This variability is embedded farms, years, soils, management, yeah, and variety as well. Okay, so the variability that you see for 100 probably. So how would we overcome the variability? The way we did was repeating the trials multiple years, because at the end of the third year, I didn't have an answer how we're going to solve the problem of fertilizer, maybe, and then because first year we had so much rain, and the third year, it was a La Nina year, almost no rain in 2013. That couldn't, unless including more data, to really couldn't decrease that variability, and to be meaningful. Well, when you conduct trials at the research station, it's one soil to reduce that, we were able to really draw more conclusions, and there is a benefit of doing that. But at that point, part of this work that was done in growers field was to get their approval and recognition. Okay, this is results from my land, and every year we measured them and showed them, even though we didn't have a conclusive, they were understanding what's happening. Would we have a other way to deal with that variability?
Well, no, in essence, you don't. I mean, it's and this doesn't surprise me that as you remove nitrogen as a limiting factor, that you narrow the variability. At the 100 rate, there's a lot of other influences that play a role. In addition to nitrogen.
Thanks for the question. Thanks. Almost puzzled me. You had one?
Well, I am a little confused here. So how do you measure the nitrogen use efficiency? Do you have liximeters there that you were collecting how much was drained, or just biomass?
Yeah, it's basically the pounds of biomass divided by the nitrogen available, and that was in the soil before planting plus fertilizer. So the availability.
So you really don't know the fate of the nitrogen that was applied there, remained on the soil there, or was leached? Really?
Well, if you go back to the fertilizer use efficiency slide, that overall 40%, 45%. So we know the plant uptake about 45% from your 200 pounds. The rest,
Horrible, in my opinion. I mean, because if it's the rest is just leached and then ends up in the water table or whatever.
Yep.
What we're trying to not do, for algae blooms and whatever environmental effect,
leaching is very likely, but there is also denitrification, volatilization. So there are these components. We didn't, but every time that we started the trial in the next year, the levels of nitrogen in the soil, the initial levels we were very low. 10 ppm, 10 milligrams per kilogram, so very, very low. So that comes the next component, that between crops, the summertime, putting cover crops to uptake the residual or to hold the residual in the biomass, and start the process of decomposition and later on. So that's another point to address, which is also BMP.
Yeah. And another thing is like the irrigation is scheduled, like you have a weekly schedule, that's it, and you apply no matter what, even if it rains or not, because I saw that you had a curve, like measuring every day,
Yep.
how it was planning, but are you using that measurement of the soil moisture content at some point and you say, oh, I'm not gonna irrigate today, or just irrigate?
So the other question is about how we manage the irrigation. For those trials in seepage, we had a water table sensor, a piezometer in the middle of the field, and opening and close the valve according to the water table target. For Andrea's study with across irrigation systems, methods, we had, Andrea he established a threshold between 11 and 16% water content, and he tried to he maintained all trials.
So the over irrigation or over water over that level was just rain, basically. So you're trying to keep a certain amount of irrigation as it should.
Yeah, to be able to be fair on the comparison, right? Okay. But I pointed out that at that time, we didn't manage the water table for sprinkler irrigation. So we didn't back up the water to supplement. So we rely only on the overhead irrigation and rain. And that's not what we should do, or farmers should do. We should kind of look at a more hybrid system, overhead, supplement, water table. Keep the water in the field as much as. So that kind of explains, similar use to sewage. All right. Well, thank you all. Thanks for the opportunity to present this work. And
Thank you.
see you next
Yeah.
meeting, right? And we have another one in
Yeah.
a few weeks.
There are going to be 2 more seminars. Next month, it's going to be November 1st, I believe. It's on the, is Alex Cleveringa. He is a grad student at Iowa State in agronomy, and he's going to come to campus and talk about his research, which concerns the effect of dropping rates when you're trying to estimate the economically optimal rate. For example, from trials where you don't have a zero in it, or when you're dropping other rates. And he took some historic data, and he's going to have some interesting effects, and that you have to be aware of when you are trying to estimate fertilizer trials. And the last presentation will be in December. That's Dr. Hans-Peter Pifo. He is from Hohenheim University in Stuttgart, and he's been looking at, with some colleagues at Potsdam, looking at the question of how to, what rates to apply, and using a Bayesian approach. And the gist of the Bayesian approach is you using prior information to, in this case, to design the new trials. So in your case, using all the information that you have and to see what rates will be applied in the future. And the Bayesian approach is really ideal for them. And he's going to come to campus and talk about that.
Excellent.
Well, thank you.
Thank you.